Okay, great. So I'm just going to log in here to the network SSH. Okay, so and we'll get going then with the automation lab. Okay, so the first thing we need to do is copy the data that we're going to use today. We're going to copy from my account. So in this case, we use cp -r home. Now this is my username, not yours, and we should use my username. So spdpod. So if you just copy it exactly like that, spm scripting lab, like that, space, and then copy it into your SPM course folder. And you must put the / at the end here. That means it'll copy the folder inside that folder. Okay. So when that's done, you can then cd or change directory into your home account, your analysis course videos. Sorry, course 2017. Now in my case, I have to go into my own version of it, because they're both in my account. Okay, and you should now have a folder called SPM Scripting Lab. So let's change directory in there. Okay. And you'll see here there's two folders, code examples and new code examples. So first things first, let's load up SPM. If you remember, there's two ways to do this. 0310, like that. We specify the actual version. However, with the change in the module system on the network, it's probably safer just to do it the other way, which is module load MATLAB, because SPM runs inside MATLAB. Module load SPM, and then SPM space fMRI. This will just take a couple of seconds to connect. Let me check this is still recording. Everything is okay. This is recording correct? Yep, that's fine. Sorry, I'm paranoid. Okay. So if we ls here, we've now got the SPM version here. So there's one other thing you can do. So when you see the two chevrons, also in a second, that is the command prompt in MATLAB. That's not the full MATLAB display. So the MATLAB display usually has a lot more information in it. So you can see here, we're inside MATLAB now. But if I do desktop, I'll get the full MATLAB desktop that people are more familiar with. However, in this case, it can sometimes slow down the graphics display, so you may or may not want to do it. If you have any problems, you might have to close the thing and reopen it without the desktop, but hopefully it should arrive in a second. And while this is up, you won't be able to use this command window. You'll have to use the MATLAB one. Okay, so this is the standard MATLAB command window. So you have the folders that we're navigating around within. So here you can see we're inside SPM scripting, inside my SPM course folder, inside my username, inside home. There's these two folders here. There's previous commands I've used. And then here, there's all these, anywhere where I create a variable, it's saved here. So I say x equals 1. Now it says x equals 1. So that's saved there. And that's useful when we come to modeling at the second level. So what I'm going to show you is what's inside the folder new in code examples. New code examples. And you see ls, we see here there's a whole lot of folders. Step 1, create batch script. Step 2, remove manual inputs. Step 3, SPM select. Step 4, plug in variables. Step 5, execute command, and step 6, use a loop. Now, in each of these cases, I've basically created, so I've created step 1. I've created a batch file, and then I've saved it as a script. That's step 1. Step 2, I've gone through, and I've manually removed the inputs that we put in. because we're ultimately going to replace them with variables. So the reason I'm showing you this is we're going to do this all now, step by step, but I wanted to show you that that I saved each step along the way, so you can manually inspect it. Let me just have a quick look and see if I've actually added some CD step 2. If at any point you want to see, so we can just type it open, you can just type in the name of the script, pre-processing batch jobs. This is outside step 2 where we're removing the manual inputs. Okay, so I've removed this part, and this is the same. Now this part here will need to change as well, but we'll deal with that later on. So this is based on my account on my Mac, so this path will be incorrect, but that's okay. And I've also removed scans here, which is, so here's the input of the T1 into slice timing correction. But I'll explain that in a little bit more detail in a minute. Okay, so the reason I'm showing you that is just to show you that those steps are all saved bit by bit. You can see where I've made changes. But we're going to go through the process now ourselves, okay? Okay, right, so let's begin. So the first step is to load up a batch that you've previously created, or to create one from scratch. So if we open this one and we go up one level, go into SPM course, which in my case the folder is slightly different, you should have a pre-processed pipeline or something like that, which we saved at the end of video 3. Okay. If you don't have it, we can go through the steps quickly here. So this is our pre-processing pipeline. So we segmented. In fact, let me. Yes, let's just create it quickly again, just in case anybody didn't have it. But you can fast forward this if you already have this process done. So SPM spatial segment. Then we're going to do slice timing correction. These are the same steps we did last time. Then we're going to do realign, estimate and reslice, co-register, estimate only, normalize right, and smooth. Okay, so segmentation is just our T1 image. And we save the bias corrected file, remember, because we're going to use that as a target for co-registration later on. And we save the 4 deformations. Slice timing correction, new session. We select the data, and if you remember, we have to filter SWA 1:300. Of course, if you've already got this saved because you finished video 3, you don't need to do this. You can just load it up and be ready to go in a second. This is just for anybody who didn't get around to doing video 3. Some people have to leave a little early. So the TR is 2, the number of slices is 38. The TA, if you remember, is the time we actually acquire data. It's slightly less, so it's 1.94 or something like that. And the formula for giving for that equation is just here. The slice order, again, our data is interleaved bottom up. So it's this formula here, 1 going up in steps of 2 to the number of slices, and then go back and get slice 2, going up in steps of 2 to the number of slices. So 1:2:38, 2:2:38. And finally, the reference slice is the middle slice in time. So I'm going to specify that as 2, but 37 is as good. It doesn't really matter. Okay. So realign, estimate, and reslice. So now we've given it the data for segmentation, and we've given it the slice timing data. So we go here into realignment, so new session, and here we don't have to manually select the files anymore. We can just use dependency. So we'll say the input here is dependent on the output of slice timing correction, and we say mean image only, and that's all we need to change. Co-registration, the reference image is dependency. It's going to be dependent on segmentation. It's going to be the bias corrected image we created earlier on. And the source, which is jiggled about to match the reference, is going to be our mean image. But we want to keep our fMRI time series in alignment with the mean image. Or it's already perfectly in alignment because it comes from realignment. But we want to keep them with it. So then the functional data is going to be lined up with the structural. So we'll say realigned images. Okay, normalization, new subject. The deformation fields, again, dependency, they come from segmentation for deformations. And then images to write, the co-registered files. So they're the files that are co-registered with T1. This deformation field is the warp field from the structural into standard or MNI space. So we take the images that are co-registered to the structural and we apply these 4 deformations to them. And finally, we smooth the data. So we take the normalized images as the input to smoothing. Okay, so that's the full batch. So to begin by creating a script, the first thing we need to do is save the script as a batch and script. Okay, and it'll ask us for a name, so let's call it preprocess. Pipeline. Okay. And it will open this script. And this first script calls a second script, which is the same name, but with an underscore job in the title. We actually don't really care about this script. We're going to circumvent it completely. So this is the script we want to open it and edit. So let's open this. Okay. And this script basically just lists all the parameters you've just put in to the batch window. Click here, batch editor. Okay, so hopefully you can see here, segmentations first. We put in the structural, then we've got bias regularization, bias smooth, full width half maximum, bias full width half maximum. And all of step 1, so this part here, to here, MATLAB batch 1 is the first step, which is segmentation. And we see we've been writing out 4 deformations. These are the inverted deformations. We're saying 0, we don't want them, just the 4 deformations. Then we move into step 2, slice timing correction. And the first thing we input is the scans, 300 files, and here they are listed. Okay, so all the 300 scans. And if you want, you can pause the video and go through those steps in a little more, a little more clearly. Just check that you're happy enough with everything. Okay, so we'll go through the other steps involved in automating this thing. So the first thing we do is we need to basically remove all the stuff that we manually put in. So in this case, it's going to be, we're going to take out the structural and we're going to take out the functional data. Okay. Other than that, the rest of the scripts, this is the same for everybody, hopefully, in the study. This is all the same, and it's all, any inputs here are based on the previous steps, so we don't need to change them. Okay, so all of this is identical, and this is the standard approach you'd use and this is what I would use if I have to do something. I'd make the batch normally with all the processes, and then I'd save it out of the script, and then I'd just edit it a little bit so that it would automate the process. Okay, so first things first, let's delete the files. It's very important to keep these curly brackets here for now, because they'll tell us what we need to do to the inputs to make sure they're in a format SPM expects. Okay, so let's go down here. So you can see I'm keeping those 2 sets of curly brackets. I'm actually going to just put them like that. Okay. So I've got rid of those scans there on line. So now in line 41, it should look like this. And line 43 should be like moving just number of slices. Okay. And then do the same thing up on line 5. Just get the contents of this folder and remove it. So line 5, remove everything inside the curly brackets. And on line 41, down to the end of the 300, remove all of those, so you end up with something like this. So I'll give you a couple of seconds to get that done. And as you can see, the rest of it's the same. And as I said to you, when I created the templates in my scripts, these point to a different location. If you create this within SPM on the network, it'll point to the correct location, so that's fine. So these are tissue probability maps for grey, white, and CSF, and dura, skull, and externally to the head. So they're kind of images that have a 1 where there's 100% probability of that voxel belonging to a particular tissue class. But it allows the segmentation, the process of breaking the image into grey, white, and CSF to be more accurate. It kind of constrains where the algorithm thinks the different tissue classes are based on what we know about the anatomy. And this is just to show you what the dependency looks like. So in realignment, estimate and write, or reslice in this case, but it's called estimate and write inside the script, we can say configure dependency, and the input here to data is going to be slice timing corrected images. And this comes from step 2 of the pre-processing. So you can see we're inside step 3 of the batch, but the input slice time comes from step 2, okay, which is what slice time correction is. Okay, so that's those 2 bits for setting a dependency. Okay, and then the rest of it's the same thing again. When we're specifying the reference for co-registration estimate, the dependency is going to be bias corrected image coming from the first part of the pipeline. Mean, the motion correction source, is going to be the mean coming from realignment, and that's coming from step 3 of the pipeline, which is realignment. So step 3, realignment. And then realigned images is also coming from step 3 here. Okay, so hopefully that's clear. All we've done here is we've gone to line 41 and we've removed all the files that went in. And then on line 5, we've also removed the string of text. Okay, so what's the first command we need to know? And basically, as listed in the handout, the first command we need to know is called SPM select. Okay, and SPM select opens up this graphics window, but obviously if we're automating the process, we don't want to be doing that, so let's close that. SPM select takes 3 inputs. Okay, the first one is basically a listing parameter. Second one is a directory, and the third one is the filter. And if it's a 4D file, it's also volume selection. Okay, so these are the 4 inputs. Let me just move this across here. Now if I click return, it's going to give me an error here. So just to remind you, fine. This is where we set the filter. Normally when we're selecting files, there'll also be a thing where you can do 1:300, and that's what this volume selection option does. Okay, so let's go through the listing parameter first. So there's a number of parameters. One is just simply listing parameter can just be list. So listing parameter. Okay, so it's just like that. Directory, I'm going to say, can just be a location. So home spd.pod, for example. Or it can be, I tend to just use pwd. So what I'm going to do quickly is I'm going to just move up 1 level. You won't have to do this because you're already in the right place. It's only because of my code. Okay, so if we do SPM select, and we say we're going to list the files in this current directory. Okay, now we need to give it a filter. So if you remember, the filter before is little hat, and in this case we're going to take the T1 file. Okay, let's see what happens if we do it this way. So here you can see it finds everything that starts with T1 file. So this filter is exactly as it would appear in the graphics window. Okay, so we searched inside the present working directory. You can see all the files that are in here for something that starts with T1, and we're just listing it. Okay, but we don't want this .mat file as well. We only want the image, the nifty file. So what we can do is we can say .nii, and tends to add a $, at the end, and that gets just the T1. So in SPM, you basically finish off the terminals of the file with like this. So backslash dot .nii with a $sign. Now, in fairness, I don't think you actually need to do all of that, but I tend to stick. That will still find it as well. But there's some cases where it can be a little more complicated, so I tend to stick to the exact format they use. But just so you know, you don't have to. Oops, sorry. Now, if you note, all of these things are inside single little quotes here. This specifies a string of text. And you'll see this in when we start to do more scripting. SPM has a number, MATLAB has a number of types of file input or variable input. So you can have, x equals 1. That's just a standard variable, okay, and it's just a number. So I can do x plus x, and that gives me 2. There can be vectors, x equals 1 to 10, and that just gives me a vector of 1 to 10. Or there can be matrices, so we say matrix matx equals 1s, as I say 2, comma 2. And that produces a matrix here of numbers. So these are just numbers. But however, to do scripting, we want to be able to point to things like directories and things like that. So we need to be able to input text. So if we say directory equals pwd, it lists that location. But we could just as easily say directory equals, open a string, like that. Okay? And now we have a variable directory that points to this location. Usefully, you then can use that to move into that location. So instead of doing cd directory, in which case it will try and move into a folder called directory, in MATLAB, if we open a bracket, it knows that this is a variable that points to a location, so we can cd into it. And we'll use that later on. Okay? So one of the things we can do is we can create a variable that points to a location, and then we can move in there using this change directory and then input the variable. Okay, so let's go back to our SPM select. So if you remember, we are listing the contents of this folder, the folder we happen to be in, for things that start with T1 and end in .nii. Okay, and that just gives us the T1. But if you remember, the input in the batch window and in the editor, but we've taken it away from the editor now, so let's have a quick look, is the full path. Home, SPDPO, in my case, all the way to there. So that's not much use to us. Let me just check if it's still recording. Yes. Sorry, I'm going to be paranoid about it. Okay. So we actually need the full path. And luckily, to do that, we just add in here FP for full path list. So we've changed nothing else. So this is the script originally, gives us T1. If we add FP, we get the full path to the file. So hopefully that's clear. And we can obviously write that straight into a variable then. So we can say T1 file equals. And now we have a variable we can plug straight into SPM. Okay? So hopefully that's clear. If not, go back and check again. But in essence, list, 90% of the time you use FP list, you don't use list. So you search for in a given directory using this filter. And the filter is just exactly the same as we've used when we're manually selecting files, except we've added this bit to say it must end in .nii. So let's do the same thing now for fMRI. Okay, so in our case, we go back to listing. Let's get rid of the variable name. But this time, we're going to say it's a task. And we get the task file. That's great. But we know the fMRI file is 300 volumes long. So let's first thing put the full path on. Actually, no, let's do this. So there's an instruction called extended list. And this comes with an extra variable, which is 1:300. So if you remember, this is exactly like we do when we do SPM select. So we're searching within the present working directory for, and we're going to list the files where we're going to extend it. And we use this filter, and we're searching for all 300 files. So these two bits here are exactly like we normally do when we use SPM select in the graphics window. And now you see all 300 volumes. Okay. And again, there is the option to add the full path. So FP. Okay, so now we see the full 300 volumes, each with a full path. And the last thing we want to do is we'll run that to fMRI data equals. Okay, so you can see here, hopefully, let's clear matx. Clear X. I'm just clearing these variables up here so you can see them more clearly. Clear listing parameter. Okay, so you can see here now we've got 3 variables plus this one which is ANS, which means answer. It always is created whenever you write something. So we have the directory. We have the fMRI data, which is a 300 rows by 63 characters long. So each of these is 63 long. And then we have our T1 file, which points to our T1 file. So again, just to confirm. And just so you know, you could also search in here inside the directory. You don't have to use the present working directory. You can search from anywhere if you have the directory specified. Like that. Okay, so we have T1 file and we have fMRI data. So let's go here and copy these 2 lines of code. So so it might be just easier to do it here. T1. Let me just copy that. And we go back to our script. And here, on line, basically, let's move line 1 down. We can leave this bit of code here for a second. So we say line 2, paste this in here. And let's go back to MATLAB. And let's look for, you can push the up arrow to get back the command. Oh, let me just do fMRI. Let me get back this. Now, to stop SPM listing it every time, you can just put a semicolon at the end. That hides the output. It doesn't stop it doing what you want it to do, but it stops it writing the full list out to MATLAB. So let me show you. So if we do that, we get the full 300. But if we had a semicolon, there, it's hidden. It's still done, but we don't need it written out every time. And that's quite useful when you script stuff. You don't necessarily want it to be writing out everything all the time. Okay. So we now have our batch script where we've taken out the T1 here that was inputted manually and the fMRI files. But we've got these functions here, these commands, that search for those files in the location you're currently sitting in. So hopefully that's fairly clear so far. The next thing we need to do is we need to plug the files in. So, and that's where this curly brackets thing becomes important. SPM is, these inputs here, these variables are strings of text, okay? But SPM is expecting what's called a cell array, which is basically just a structure that holds information, holds strings, holds matrices, things like that. So, and that's indicated by these curly brackets. So, if we want to input this file, so T1 file is this, but MATLAB's expecting it in this format. These are character strings of text. You can see the string because of the single quotes. But SPM's expecting a cell array. So there's this command called cell string. Ooh, T1 file. So this converts the file into a cell array. So we'll just call this T1. and it changes its format. You can see here's the string, and now here's the T1. So I said T1 is the cell string of this. So this is basically taking this string and put it inside a cell array. And again, this is just a different, and you can basically indicate it. You can get access to the string that way. Okay? So this is just a different way of holding information inside MATLAB. So as I said, there's matrices, there's vectors, there's character arrays, which is just basically the letters, there's strings of text, and there's cell arrays. You don't need to know a huge amount about them, other than to be able to execute this part. But I'm going to show you everything you need to know, so hopefully it should be okay. But if you're interested, you can look more into it. So because there's one set of curly brackets in here, we know it's expecting a cell array. So we can just basically plug in cell string T1 file. And that should work now. So it's taking this file that's found and it's converting it into a cell array of strings and plugging it in. We have our fMRI data up here. And so that's at what's now line 8. So I added 3 lines at the top here. And what is now line 44, you can see here there's 2 sets of brackets. So what you saw when I did this earlier on was I listed the contents using this curly brackets 1. So we'll do the same trick here. So we'll say scans curly brackets 1 equals cell string. So this basically, first one, puts the curly brackets around it, but it's inside another set of curly brackets which are specified here. So hopefully that's clear. But that's why we needed to keep, this is a comment here. So this is basically just a set of curly brackets. So this is to say there was 2 sets of curly brackets. So by doing that, we take a cell array of cell string, that creates 1 set of curly brackets, and then we indicate this to say put that inside another cell array, which is scans. And at that point, assuming you start in the right location, this will create the batch script you want. Okay? So it's very simple, there's no big deal. So we would want to save it, so we'll save, and we'll call it preprocess pipeline batch. And we want to save this name here, MATLAB batch, copy, because that's the name of the structure that contains all the information. Okay, so that is the batch file. Once that's been created, you then can load it up manually, and I'll show you that. Okay, so now we can just save this, save as preprocess pipeline phase 1. And we'll make sure we're in inside. Yep, that's there. So in fact, you can now just press this little green arrow to execute it, and hopefully add it to the path. And if we list, so actually you can see it here now, hopefully, this file's been created. So this is the one we made yesterday, and this is the one we've just created. So just by executing it, it runs through and saves it, and we can then load this into the batch editor here. Oh, I need to move to the correct directory because I'm not in the right directory, but you will be. Pre-processing pipeline batch. Oh, I made a mistake. Oh, it doesn't like something I've just done. Let me just check that. So that part should be okay. So the one part that usually causes problems is here. It's just 2 sets of curly brackets, and the reason is it seems that some versions of MATLAB don't like doing it one way. Let's try that again. There we go. Okay, so you can see here, it's a quirk of the version of MATLAB. But this, so in the past, I used to specify curly brackets 1 equals cell string. But in this case, and I think it's a newer version of MATLAB issue, it won't take that, so you just have to put these sets of curly brackets around that, okay? Technically, you could probably do cell string on that again, but it might give you grief because it might say it's expecting the input of the cell string to be a string, not a cell array. So rather than doing what I just did, this is the way to do it. Okay, and we'll save that, that's fine. So that creates, as you can see here, we've just put curly brackets around cell string. That works. Okay. So that's basically step 1. So we now have a batch that works. Okay, the T1 has been inputted into here, and the fMRI files have been inputted into here. So we could just press play here, but we don't want to do that. What we want to do is to automate the process. So the last command here for executing the script is this one, spm jobman run MATLAB batch. So this just executes the script. It runs the MATLAB batch in SPM. Okay, we can save that. So now if I press play, it won't just run this, it won't just create the file, it will actually execute it. Before we get on to looping over, so going into different directories, there's one more thing we need to do. And that's to clear the MATLAB batch afterwards. So if you're going to run lots of different scripts, they can often interfere with each other, especially if you run a pre-processing one after a batching one. These elements will stay inside the batch because it's specified by a different structure. So if I did a pre-processing, a modeling script batch afterwards, modeling has 3 steps, not 5, or 6, sorry, 6 here. So you'd get a whole load of the 2 things being mixed up. So we use clear MATLAB batch before we start another batch, so that's good. Okay. So there's the 3 commands that you need right now. So save, pre-processing pipeline batch, and then give it the name of the thing you want to save into, and you get a .mat file, basically. This then executes the script, and then finally we the batch, and then we clear the batch setup. So we'll run the next subject. So hopefully that's clear so far. The next thing we want to do is to basically fully automate the process. So next thing we need to do is we need to create some directories. So the first thing to do is to talk a little bit about looping. So for those who've done a bit of programming, looping is a very straightforward thing. For those who haven't, it's quite a weird thing. So in a loop, you create a variable, let's say I, and it equals a number. Okay? But we take that number and we use it to point to a file or a location or something like that. And then we do something with it, and then we add a number to it until we reach a certain level. So let me demonstrate, it's not that easy. So we'll start with, we'll say for I equals 1, 2, 10. So this means I will start at 1, it'll do something, and then I will become 2, and then I will become, and then do something. Then I will become 3, and then it will do something. And it'll keep going until I equals 10, it'll finish then after that. So I equals, we'll say I, in fact I think I'll just do that. And then we end. So we say for I equals 1 to 10, do whatever's inside here, and then end. This stops the loop. So what it's going to do is going to go I, and hopefully it squares the values. So when I equals 1, I squared is 1. Then it goes to I equal 2. 2 squared is 4. Then I equals 3, 9, 16, 25, 36. So you can see I'm taking the value of I and I'm squaring it. Hopefully that makes sense. But that doesn't, we don't have to use the number that way. So let's say we have a list of things we want to use. Let's say we've got a list of folders, so let's say cell array. So cell, so let's say, if we create a cell array, that points to some subject folders. So we were using BRC crib yesterday. 01 BRC pilot. Okay, so here's just 2 folders. Okay, so we've got a cell array that has these 2 subject folder names. I can select one of these now using I. So if I say I equals 1 to 2, dir, sorry, let's do for I equals 1 to 2, dir, curly brackets, I, end. So we say we're going to loop go for I equals 1 to 2. We're going to select the corresponding element of this matrix. So we first, on the first pass, BRC crib, dir equals BRC crib 01. On the second pass, it's this one. But of course, we don't have to manually select that. We can say length of dir. And that allows it to be more flexible. So all a loop is doing is basically using this as what's called a token for a number. And it's plugging it into some operation. But it's quite useful for selecting things. So you can see, hopefully, that if you had a whole lot of subject folders here, you write this loop, it would go into one subject folder, execute something, then go to the next subject folder, execute something, and that's what we're going to do now. So, go to MATLAB, the script. So, first things first, we'll create a root directory. So this is basically like a study directory where all your subject files are. So in our case, it'll be your username, whatever that is, and then SPM course 2017. Okay, now in my case, I should also say anywhere you see these percentage signs, they're comments, and the MATLAB will ignore them. So in my case, it's going to be root equals home spdpod spm course 2017 Owen. So mine's a little more complicated because I made a bit of a mess up when I was copying it. Okay. Actually, let's do it slightly differently. Let's take that bit away. Okay, so that's our root directory. And inside that directory, we would expect to see all our the files we want. Okay. So let's create a cell array called subdirectory equals. And in this case, this is where we'll put SPM course 2017. Okay, so that's one subjects folder. In the other case, it would be, you know, e.g. BRC crib 01. Okay, and you can have multiple subjects here. So, well, let's put BRC crib 01. And then what we say is we open our loop. So we say for I equals, I don't quite know why I is near enough always the first thing people use. I, J, K, for some reason people tend to use those when the code, this can be any letter you want. It doesn't have to be I, but people tend to use I for some reason. For I equals 1, 2, the length, so this way if we keep expanding this out, it'll be okay. So we'll say the length of this we then need to close off the loop. So end. So it's always like that. So we're going to say, here's a loop. For each one of these, we're going to do something and then end the loop. So at the end, we add an end there. And now we've set up a root directory. In your case, it'll be this. And a subject directory. We don't actually want this one here, so I'll get rid of it now, but that would be absolutely fine. Okay. So far is everyone with me? And we've opened a loop here. And this stuff we've done before. Technically, all this part here can just be deleted. So the last thing we need to do is we need to get into this directory. So we've got a root directory, and we have a subject directory, and we've got a token that counts that loops over these subjects here. So what I tend to do is do sub_dir equals, and you can do this a number of different ways. You can do it like this: root sub curly brackets I. Okay, so this basically takes the root directory and slams it together with the ith. In this case, it would be the first, but if there was more than, then it would do it for the first, then go back and change this to 2, and would take the second one, and then run through, and then go take the third one. Okay, and that's now a variable which points to that location. So we can do cd sub_dir. And that's it. And now we're in the right directory because we're inside SPM course 2017 inside your root directory. So it's CD's in there and it executes. Now you'll notice here we've got this / at the end. That's very important because when you slam these two together, if that isn't there, it'll be username and then straight into SPM core. So you need to put this what's called a file separator in there. If, for example, I'd left this out, I would just need to put in file sep like that. Okay. However, in most of your real studies, you won't have something like this. You'll have a study name, and then there'll be subjects folders, and inside the subject folders there'll be nifty folders, and inside the nifty folders there'll be a data folder, but it'll be called something 00, something like that. So here you can add on another string. So we'll say nifty, and again we're adding this / at the end because there's no / here. If you've used the symbolic links we talked about before, you just put data. And that's it. Now let me show you what that looks like. So let's specify root is equal to this. So root equals that. Your subject directory equals this. And let's go and we'll say I equals 1 just to, I equals 1. Rather than looping over for now. So then if we take this, we won't use the nifty part for the moment. And we put square brackets there. You can see now it's slammed those two things together. It's taken the home username, which was here, and added on this part to give us the full path. Okay. Now in my case it's slightly different because mine's like this. So now we've got this is the path to my files, so I can do cd sub_dir. And now I'm in the right location. and the rest of the script will work fine. So we can execute these 2 bits. And that works grand. Okay, so hopefully that's fairly straightforward. Go through it again slowly to make sure you're happy. But in essence, this is just a basic loop which is going to go take the first one here, then the second, and the third, and the fourth, and in each case create a directory that moves inside. So it adds the root directory to the subject directory. You can add on extra strings to point to folders within folders, and it goes in there and executes. There is an alternative command to this approach, and that's subdir equals string cat. So you can concatenate strings. Concatenate just means slamming together. So again, here be root, comma, sub here, curly brackets I, vid8 data, curly brackets. So both of these are equivalent. I'll show you that. Okay, so again, we're taking this string root, this string, which is inside a cell array, so we're selecting the string from inside the cell array, and then this string of text here, and we're slamming them all together, or we're concatenating them. So remember, this is a string inside a cell array. So we're selecting the string we want, and we're slamming them together. Both of these are equivalent. There are situations where this is preferable, but in most cases either will work fine. So whichever you're most comfortable with. So this is just slamming them all together. This is concatenating them in a slightly more formal way, but it does the same job. And with that, we're done. Nope. Cancel. No, no, no. Okay, so hopefully that's clear. If you have any questions, I'm happy to go through them and answer them. So what we're going to do now is we're going to do the same thing for the pre-processing, for the modeling of the experiment. And then we'll see, let's just see how long this lecture is so far, 51. So we'll do the same thing for the modeling, but we'll do it slightly quicker. So one thing you'll notice when you see people code is you don't need to recreate the wheel each time. Okay, so let's open a new script. Well, if I want to move into my data, this part's all the same for everybody, in fact. So I can copy this into my new script. And we'll do the end. Okay, so now I need to plug in a whole lot of stuff here. In fact, I also can go down to the bottom and grab all this stuff here. So you'll see this when people write codes, they rarely write code purely from scratch. They hack bits they need from other scripts. So then we cd into subdir. Okay, so with this script, I'm going to get rid of this just because it's a bit confusing. Okay, we've got a root directory. We've got a list of other directories. Okay, we're going to loop over these one at a time, selecting the string we want, put it together to give a path to a directory. Move in there. We'll do some stuff. We'll call this pre-processing. We'll call this modeling batch, modeling pipeline, and that's the basic format. You're in the right directory, and then you just have to find the things you want and plug them in. Does that make sense? So that's the basic template for any script in SPM. You just need to basically find the files. So let's go and find the files we're going to need. So for modeling, and just steal these bits of code again. So when we're modeling the data, we don't want our task files anymore. We want the smooth normalized files, so SWA. Okay, we don't need our T1 anymore, but we do need our motion parameters, the text file, which we used earlier on, which we used as a nuisance regressor in SPM. So we included in the model, if you remember, there was 6 columns towards the end, which were the motion parameters. So we'll call this RP file. And we'll use full path list, and so we'll say if you remember, it begins with RP underscore. Now, one of the things, I'll change this to .txt because it's a text file. So let's see if this works. We get rid of the semicolon. Then you can see that's found the file we want. Okay, so that code works. So at this point, we have a root subject directory. We're creating the full path to the data, the subject directory where the data actually is, and moving in there. We're searching for fmri data, and we're searching for our RP file that we need. And again, we can just change the terminus from nifty to txt here. We're saving it out, we're executing it, and we're clearing. So now we just need to put the actual MATLAB batch bit in, which we're going to create. There is one other thing we didn't put in here, which is onsets. So I'll explain this in a second. So we're going to search for something called select fplist pwd onsets. We'll just call it .star.mat. That doesn't exist yet. We're going to create that in a second. Okay, let's do that now, actually, to begin with. So what we need here is the onsets file. We need the onsets information from the thing. So let me just have a quick look and see if we've got those step-by-step modeling. So this is the information that was in the modeling script on here. These are the onsets. So if we copy these things here and paste them straight into MATLAB, we now have some variables. Okay. And we do the same thing for the durations. This is a slightly inelegant way, but I can show you a slightly more elegant way later on. This will do the job. And what we do is we save then the variable onsets, and inside that we save control, queued, free. So these are the variables which have now been created here when we pasted it in, and we're saving them inside and you should hopefully see now there's a file called onsets.mat. So if we clear these variables, clear, they're now gone from here. If you want to see the list, you can type in whos. That shows you everything that's in the workspace. WHOS. Now, if we load onsets.mat, you can see if we type in whos, these variables have reappeared. Okay, and that's what we're going to use in our script. So we're going to search for the file that's called onsets.mat, and then we're going to load onset. Okay, so we now have a script that goes into a folder. We can get rid of that folder for now. This one's just commented out. It goes into the subject-specific folder, creates a full path to the data, and copies it. So obviously, in our case, for SPM course, if we're going to do loop 1, you can just set it like that, because there isn't a nifty file, but nifty path. So if it's like this. So for today, we just want that, because that's actually what we're going to be using. We move inside there, we search for the fMRI data, we search for the RP file, and we load it, search for our onsets file, and we load it. Let me just check that that's correct. It is called onsets and not onset. Yeah, onsets, great. And now we just need to create the batch. So again, we have saved one, I think, previously, but I'm going to run through it quickly. So let's go new batch. So SPM stats model specification, SPM stats model estimation, and I'm actually going to add the contrasts as well because I know what they are. So let's go SPM stats, contrast manager. Okay, so we need to give it a directory, which we'll say here, done. The units for design in seconds, and again this is all in video 2, so or video 3 I think. Oh, sorry, actually video 4. Right, this is the number of slices, 38, and this gives a reference to date and design, new subject, and again here we set it up manually as we would, and then we'll edit it. SWA 1:300, select all. Okay, multiple regressors, if you remember, is our RP file. So we'll select our RP file. And finally, we need to set up the conditions. So we'll set up 2 conditions here. Test 1 to 10, 1 to 20. And this is just because I want to see the format that it's saved in. So I'll say 2. And this is quite useful. If you're not entirely sure what format it's expecting, you can set this up this way. So we'll say 3, and that's fine. And then duration is 1. That's fine. Okay. Model estimation is just dependency. We take this. And for the contrast manager dependency, we take the model estimation. And now we want to create 2 contrasts. The first one is going to be free minus queued. And we're going to set it up so the free is the first column, Q is the second column. So we can say 1 space minus 1. These orders dictated by how you specify it in here later on. And the second one then is all motor minus control. So in our case, that's going to be 1 space 1 minus 2. And we now have a script. So let's save this out. So hopefully that wasn't too fast. We've just basically inputted the same information as before. So again, the point of it is you can stop the video, go through and check you're happy with everything I've inputted, and run over it again. But this is the same thing we did in video 4. Actually, sorry, I stand correct because we did the coding in video 4. Video 5, the modeling video from yesterday afternoon. So save batch and script. We'll call this model script. And again, we'll get 2 scripts opening. Well, get 1 script opening, which is the script that points, so you can see this, it points to model script.job. It's the model script.job that we want. Okay, and again, same thing here. We highlight the bit we don't care about, we get rid of it. So that's on line 5. Here, all the contents of the folder. But you'll notice here there's only 1 set of curly brackets. So we need to make sure we note that. So we'll call this free. And we know if we've loaded our onsets, the first condition is called free. And this is called dur. Oops, sorry. Okay, and this is all normal, so we get the second condition, which is queued. And the onset is queued. So again here, we have this variable that's been loaded up in here. Once we've loaded this up, these variables exist in the workspace. So just to remind you of that, here they are. Okay, so we can plug those straight into the script. So we've created 2 scripts here. So we'll just call this, sorry, dur queued. So we've got the code for 2 conditions, but now that we know the format, which is we specify the condition number here, we can copy line 17 to 26, and we can paste it in again. And then we change this to 3, 3, 3, and this one to 4, 4, 4, 4. Okay, and this one's going to be control. I missed the onset of the name. I take it back. Sorry, we need these folders here. We need the name part as well. Copy. 3. Okay, so we've basically got each condition needs a name, an onset, a duration, a tmod, and a pmod, and this orth, which tells whether to orthogonalize or not. So, control. And the last thing is instruction. And so again, we just want to check that the variable is called exactly as the way we're calling it. So do instruction, these are all lowercase, these are all uppercase, that's correct. So that's fine. Okay, and again, the RP file here needs to go. Okay. This is all, see here the contrasts are specified. So that's the basic recipe. So we now need to plug in the variables. So let's do one thing. So first things first, scans. So you can see this is a single thing, so we can just do cell string fMRI data, wasn't it we called it? fMRI data, yeah. Okay, so that's now in the format it's expecting. Same with multiple regressors, it's expecting like this. So we call the variable RP file. So here, cell string. Okay, and that's it. So we've loaded the onsets. So the only thing we need here is directory. So I'm going to put this like this. Now this usually works. PWD. So we're saying it's going to be the string. The current working directory is going to be inside the cell array, position 1. And then we can copy and paste this code directly. So you can see here, all we've done basically is we've specified that the conditions will have these things as the inputs, the onsets and the durations. We've inputted the multiple regressors here that we found, and we've inputted the scans here. It's expecting us to give it a directory, which we're going to do now in a second. So we copy this across. So I'm going to paste this here at line 17. And we can just get rid of this bit here. So now we have a batch script that basically goes through, creates the model batch, saves it, runs it, and clears it. So the last thing is it's expecting us to run the analysis in a specific directory. So what I tend to do is here, I'd use make directory analysis. Call it analysis 2 if you want to test. And then you cd, and it's not a variable, it's a location, so we can specify it that. The last thing I tend to do is delete the spm.mat, because that avoids getting asked if you want to, if you try and run a script where there's a folder, there's already an spm.mat created there, and you try and create a new one, it'll say, do you want to overwrite it? So I just delete the spm.mat and to execute it. You don't need to have that, that's fine, but it's something I tend to put in. And that's it. So we'll call this save as, where did you save the other one? So yeah, so we'll just say modeling batch. Oh, spell modeling. Oh, sorry, in MATLAB, if you don't, sometimes it automatically is smart enough to, if this is set to all files, you need to put it .m. And now it's the script format. And that's it. So I think that's it with the videos. Hopefully you can see, really, there aren't that many commands, and the key thing basically is to get, you know, the first step is to create a new folder, new script. Here, copy the basics that you need. So work out the path and then put in the end here. So pretty much every SPM automation kind of begins like this. Well, it begins and ends like this. So you set up a root directory and some subject directories. You loop over the subject directories, creating this variable sub underscore dir. You move in there, search for whatever you're going to need for this batch, plug it into the batch, and then save it, execute it, clear it. So I'll leave that there. That's the basic template for any SPM automation, pre-processing, modeling, whatever. Okay, and that's it. So hopefully that was useful. And I'll see you when, if you have any questions, I'm happy to answer them now. Cheers.